Dear students, in this video we are solving some examples on geometric series. Before going further, if you didn't subscribe this channel, so subscribe it and like the video. The first example is this some first 50 terms of geometric series. This geometric series in which the first term is 3 and what is r? The r is 2 by 3 and n is 50 because we are adding first 50 terms. How r is 2 by 3? Because if we divide second term by first term, so we are getting 2 divided by 3, and if we divide third term by second term, again we are getting 2 divided by 3. So r is 2 divided by 3 because both second term by first term and third term divided by second term both are giving the same answer. So r is 2 divided by 3, and as 2 divided by 3 is less than 1, so the formula will be Sn is equal to a1 1 minus r power n divided by 1 minus r. This formula is used because r is less than 1. By putting the values, r is 2 divided by 3, n is 50, and first term of the series is 3 and 1 minus r, so 1 minus 2 by 3. 1 minus 2 by 3 is giving 1 by 3. So 9 1 minus 2 by 3 whole power 50. Two divided by 3 whole power 50 is giving the answer this, and subtract this answer from 1, it is giving this thing, and this answer is multiplied with 9, we are getting 8.999, so on up to 84, and it is approximately equal to 9. So this whole series up to 50 terms is giving the answer 9. In this example, we are to add first 10 terms of this series, 2 plus 6 plus 18. In this, the first term is 2 and n is 10 because we are adding 10 terms of geometric series. So this is the geometric series because each time 3 is multiplied. 3 is multiplied with first term to give the second term, and then second term is multiplied with 3 to give the third term. So this is a geometric series in which r is 3 and 3 is greater than 1. So the formula will be used as Sn is equal to r power n minus 1 divide r minus 1. Now putting the values, first term is 2 and r is 3, so 3 power 10 minus 1 and divided by 3 minus 1. So 2 multiply 3 power 10 minus 1 divide 2. 2 is cancelled with 2 and we are left with 3 power 10 minus 1. If we calculate this by calculator, so 3 exponent 10 minus 1, and the answer is 59048. So this is the sum of first 10 terms of this series. Dear students, in this example, we are to find the sum of the given finite series, and this is a geometric series. In this series, the first term, second, third and so on are given, and the last term is also given. The last term is 0.3 power 59. So this is the nth term because we are not knowing the number of terms in this series. The first term is given, second term is given, third term so on, these are given, but how many terms are there in this series we are not knowing. So what is n? That is not known. How we will find the value of n? So this is the nth term, and we know that for geometric sequence geometric series, the nth term is found like this. an is equal to a1 r power n minus 1. An is given 0.3 power 59 and the first term is 1. So 1 multiply r. R is, what is r? R is 0.3, because if we want to obtain the second term, we will multiply the first term with 0.3, and when we want the third term, we will obtain it by the second term multiply by 0.3. So r is 0.3 power n minus 1. So 0.3 power 59 is equal to 0.3 power n minus 1. The bases are same, so powers will be same. So 59 is equal to n minus 1, and n is equal to 59 plus 1 is equal to 60. So this series, this geometric series is having, and this is a finite geometric series. So this series is having total 60 terms. Now we will add these 60 terms. And what is r? R is 0.3. The first term is 1, and n is now 60. So, and r is less than 1. So formula is Sn equal first term multiply r1 minus r power n divide 1 minus r. So 1, this is the first term, and 1 minus r power, what is r? 0.3 power 60, and divided by 1 minus r. What is r? 0.3. So 1 multiply 1 minus 0.3 power 60 in bracket, and then divided by 1 minus 0.3 is 0.7. Now we will calculate this by calculator, and the answer is 1.42857. So this is the answer. With this I end the video, and if you didn't subscribe this channel, so subscribe it and like the video. Thank you.